Hello, everybody. Let me tell a few words about me. This is Sripriya Rajagopalan, and I have done my MCA, Master of Computer Applications, with degree in mathematics, and I am a gold medalist in both. I have about 15 plus years of experience working in MNC software companies like Wipro, Provances, Northwest Airlines in the position of project manager, offshore coordinator. I have always got a passion for teaching, and I have been working as professor and acting head of department for engineering college for quite some time. I have also been associated as external professor for brilliant tutorials, and I have authored the materials of GATE, IIT GATE for brilliant tutorials. Apart from this, I have also taken various classes for maths and computer science for various students and also associated teaching with foreign universities. This is to say in short about me. So now I'm going to give you a small session in maths in a topic called as prime factorization and LCM. So let's go into that. Let me share the screen with you. So first, let's start with the prime numbers. So what is a prime number? A prime number is nothing but a whole number. It's a whole number that is greater than 1, and the prime number has only two factors, 1 and itself, the number itself. Okay. So a prime number is nothing but a whole number, and it has only two factors, 1 and itself, and is always greater than 1. So the opposite of prime number is composite number. So let's see what is a composite number. A composite number is again a whole number that is greater than 1, but it has more than two factors. So we have seen what is a prime number and a composite number. A prime number is one whole number which has only two factors, 1 and itself, and it is always greater than 1. I told you composite number is also a whole number and it is also greater than 1 and has got more than two factors. So what about the number 1? So you must be curious whether it is prime or composite. Remember that the number 1 is neither prime nor composite. Okay. Number 2 is the only prime even number. Okay. So prime numbers less than 50. I'm mentioning a few numbers. 2, which has only two factors, 1 and itself. 3 has got only two factors. What? 1 and 3. 5, it has only two factors, 1 and 5. So 2, 3, 5, 7, 11, 13, 17, 19, 23, all these numbers, 41, 43, 47, all these numbers have only two factors, 1 and the number itself. So these are all prime numbers less than 50. Okay. Now, what is a prime factor? Having known about prime numbers and composite number, what is a prime factor? In number theory, the prime factor of a positive integer or the prime numbers that divide that integer exactly. Okay. So we will see the prime factorization. What is prime factorization of a positive integer? It is the list of all integer prime factors together with their multiples. So the process of determining these factors is called as integer factorization. So now let's see an example. Prime factorization of 864. So how to do that? 864 is 32 into 27 gives you 864. What are all the prime factors of 32? 4 and 8. 8 4s are 32. 9 3s are 27. Again you can divide 4. 2 2s are 4. 8 can be divided as 2 into 2 into 2. And 3 cannot be divided further. 9 can be divided further as 3 into 3. 3 into 3 with the two factors of 9. So how many 2's you have at last? 1, 2, 3, 4, 5. So 2 power 5. And how many 3's you have? 1, 2, 3 into 3 cube. This is the shorthand way of writing the prime factors. Okay, prime factorization of 864 is 2 power 5 into 3 power 3. So now I'm going to give you some questions. True or false? Yeah, first question, true or false? All prime numbers are odd. Is it true? No, false, because 2 is the one is even number and it is prime. What is the smallest prime number? 2. You must not say as 1 because 1 is neither prime nor composite. So 2 is the smallest prime number. The third question, true or false? All even numbers greater than 2 are composite. Is it true? True, because all even numbers are divisible by 2. 4, 8, 6, all even numbers are divisible by 2. So they are all composite. Fourth question, out of the A, B, C, D options, which number is prime? A is 12, B 6, C 9, D 7. 12 is divisible by 2, 6 is again an even number, 9 is divisible by 3. So the only prime number here is D option 7. Okay. Now, the fifth question. Which number is composite? 21, 2, 13, 11. Which is composite? Which is divisible? 13 is a prime number, 11 is a prime number, 2 is the only even prime number. So 21, which is divisible 7 into 3, right? So 21 is the composite number. The next question, sixth question, which number is prime? 27, 31, 1, 39. Which is prime here? 27 is divisible, it is composite number. 39 is divisible, it is composite number. 1 is neither prime nor composite. So the only prime number you have is option B, 31. The next question, which number is composite? A1, B 57, C 17, D 41. Which is composite here? 1 is neither prime nor composite. Option C is a prime number. Option D is a prime number. Option D is a prime number. So option B is the only composite number. Right? Which number is neither prime nor composite? Simple. A15 is composite. B41, C18 is composite. D1 is neither prime nor composite. The option is B. The next question. Which is prime and which is composite? A is what? It is composite. Because A2s are 16. B is composite. C29 is prime. D30 is composite. E31 is prime. F33 is composite. G81 is composite. H97 is prime. I100 is composite. J101 is prime. Understood the prime and composite concept? The last question, 10th question. List all prime numbers from 2 to 31. So 2 is a prime number. 3, 5, 7, 11, 13, 17, 19, 23, 29 and 31. These are all the prime numbers from 2 to 31. Now, having understood the concept of prime factors, now let's move into the concept called as LCM. LCM stands for least common multiple. So how to find least common multiple? By using the prime factorization method we discussed. Okay. So we write the prime factorization of each of the given numbers, and after that how we find the LCM is, the LCM is the product of all different prime factors of the numbers using the greatest power of each common prime factor. Greatest power of each common prime factor. I will explain with an example. What is the least LCM of 36 and 14 by using prime factorization? How to find this? Let's see. So 36, first you divide it. 36 divided by 2 is 18. 18 divided by 2, 9. 9 divided by 3 is again 3. 3 divided by 3 is 1. You cannot divide 1 further. Now 14. 2 sevens are 14. 7 divided by 7 is 1. So to find the LCM, so we multiply all prime factors. But common factors are included only once. So what 36, how you write? 2 square into 3 square into 1. 2 into 2 into 3 into 3. So that is 2 square into 3 square. 14, how you write? 2 into 7. So now, how you find the LCM? 2 square, you have to take the common prime factors first. You have 2 here, you have 2 here. But 2 power 1 here and here 2 square. Which is bigger? 2 square. So you write 2 square once. You have 3 square here, you don't have 3 here. So write the 3 square as such. You have included 2 once. 2 square you have included, highest power you have included. 7 is not included, it is uncommon. So you write that again. So the LCM is 2 square. Common factor, you take the highest power and also fill up the other uncommon ones. So 2 square into 3 square into 7, that is 2 into 2 into 3 into 3 into 7 is 252. That is the LCM of 36 and 14 is 252. I'll give you one more example for this. What is the LCM of 5, 4, 16 by using prime factorization method? We'll do that. 5 divided by 5 is 1. 4 divided by 2 is 2. 2 again divided by 2 is 1. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Now I'm going to write 5 is 5 into 1. 4 is 2 into 2. 16 is 2 into 2 into 2 into 2. LCM is, I'm going to write the 5 as such. You have here 2 square. Here you have 2 power 4. Which is greater? 2 power 4. So I'm going to include only 2 power 4. So 2 power 4 into 5. That is 2 into 2 into 2 into 2 into 5, 80. So the LCM of 5, 4, 16 is 80. So with this, we complete the session. We will see in detail in the later sessions. Thank you.